Introduction to electrical vehicles. In this, we'll see the electric vehicle introduction and overview of electrical vehicle history. So the important questions: what is electrical vehicle and why electrical vehicle? If we see, the 20th century has witnessed the rise of serious environmental, economic, and social concerns related to greenhouse gas emissions because of the IC engine power transportation. So a lot of emissions are there and environmental concerns are also raised. And these concerns has reshaped the manufacturing industry, and it has forced the manufacturers of the automotive industry to rethink about the automotive sectors considering the greenhouse gas emissions and pollutions. So this is the need of today's industry to go for the pollution-free transportation sector. Now, in this view, electrification of transportation is the primary need, and that will provide also a sustainable environment and solutions. If you consider the existing transportation, it is called as a transportation 1.0 paradigm. So here in this transportation, we have IC engine based transportation, and it is using the fuel to run the IC engine, internal combustion engine. It may be petrol, it may be diesel, or any kind of fuel that is used for the IC engines. Now, these are the conventional automotive technologies. Also, if you see, the efficiency is very less for this type of transportation or automotive vehicles, but it is accepted that the efficiency range is accepted for this. But because of that, you can see the powertrain efficiency is reduced and it is stagnated. So due to this reason, along with the environmental concern, we are now shifting to transportation 2.0. So this transportation 2.0 is going to focus on electric drive vehicles, and it will reshape the automotive industry, and focus is on the most efficient source of motive power, that is use of electrical energy. If you see the future need for EV development, electrical vehicle development, we require industrial and academic investment for this. Hybrid and plug-in hybrid and full electrical power trains has to be developed to achieve the dream of 2.0, transportation 2.0 paradigm. Development of superior electrical motors, which is the powertrain for the electrical vehicles, and power electronic controllers is required. There will be need of embedded software for these EV controls and EV operations. Also, batteries and energy storage devices, other type of energy storage devices such as supercapacitor, these are to be required. These are required. Micro and smart grid interface systems are also required or are the part of this electric vehicle technology. In addition to that, highly skilled workers who will understand the theoretical and practical aspects of advanced electrical drive technologies, they are required. And this need is required to fulfill the dream of 2.0, and it may require next 20 years. So the sector will develop and the need of these things will be for next 20 years. If you see the history of electric vehicle, surprisingly, the earlier transportation sector started with electrical vehicle itself about 185 to 190 years ago. The first EV was a battery-powered tricycle in 1834. Slowly it developed, but the price was the main concern considering the electrical vehicle. The price was so high. It is quoted that the cost was equivalent to a Rolls Royce, that is roughly 6.21 crores. And because of this, the popularity of electrical vehicle was reduced. And meanwhile, the IC engine was invented by Henry Ford, and that was the finishing time again for this electrical vehicle. So it is said that a man with an idea that finished off the electrical vehicles for good. So it was good for the society to purchase the vehicles with low cost and fulfill their dream for the transportation purpose. So EV was again out of the picture. So for T model, it was offering a good range and very low cost. So by 1930, almost electrical vehicle vanished from the scene. So EV started the outbreak of the energy crisis and oil shortage in 1970s, during the 1970s. So slowly it started developing. And if you see the history, it has uh, started developing year by year. So if you see the timelines, in 1901, the first hybrid electric car that was developed by Porsche. 1908, the Ford model was introduced by Henry Ford. Likewise, in 1960s, interest in electrical vehicle regained as fuel prices were increased. Then we see the timeline slowly up to 1996. General Motors also launched EV1. In 2006, Tesla also announced the production of luxury electrical cars. In 2009, US Energy Department invested in charging infrastructure. After we see in 2010, General Motor introduced first PHEV, Tesla introduced Model S, and slowly it go on increasing. 2020, China's expectation of 10% of auto imports and production was there for electrical vehicles. 2025 was the expected date by Norway, Netherlands to plan was planned to ban the sales of petrol and diesel cars. If you see, in 2030, India plans to promote an all-electrical car fleet. It is expected date. Also in 2040, Britain and France announces to ban the sales of all new petroleum-based vehicles. This is how it has again taken upper hand in the market. So these are some models we can see. So electrical vehicle can be available in all different forms: locomotives, golf cars, forklifts, buses, nuclear submarines, and obviously they are also in the elevators. So these are few models: hydrogen fuel cell based car, solar racer type of vehicle, hybrid car, MIT city car, that is one model developed by MIT, full size battery electric car. Now, if we see, there are various companies and they have various models. These are few models. If you see Tata Nexon EV, especially which are launched in India, which are available in India, MG ZS EV, Tata Tigor EV, Hyundai Kona electrical vehicle, Mahindra e-Verito, Mahindra E2O Plus. So these are few models, and their prices are also significantly in the range. We can see details for few cars. Just the links are given here. For an Hyundai Kona, you can see the detailed specification and features on their website. Mahindra e-Verito, Tata Nexon EV. So similarly, we can get various brands, various companies which are providing these EVs, and we can see the specifications. This is a list of few EV producing companies, their current electrical vehicle models and upcoming models. Obviously, few models are already into the market, though it is as upcoming models is written here. So BMW, Fiat, Ford, GM, Honda, Hyundai, Kia, Mercedes, Mitsubishi, Nissan, Tesla, Toyota, Audi, Porsche, Volvo. These are the companies. And if you see their models are i3, i8, Focus, Fusion, Volt, Spark, Accord, Smart ED, Leaf, Roadster, Model S, Prius. Also, new models are launched regularly. Yes, if you see, we have discussed about the scenario why EV is required. So we can see and promote the use of electrical vehicles considering the environmental concerns and the need of this EV. After this brief history, we'll go for this EV configuration. Especially the EV configuration will divide it into three important blocks. One is the energy source subsystem, another is the auxiliary subsystem, and next one is the electric propulsion subsystem. If you see the energy source subsystem, it will be energy source. For example, the battery is one of the energy source. Then energy management system will be the part of this energy source system, and energy refueling unit, that is charging and discharging, will be the part of this energy source subsystem. Once the energy source is connected, it will give input to the electric motor via power converter. So here we can see the power converter. So this is the input from this energy source to the electric motor, and then motor will drive the mechanical transmission and it will given to the wheel. So propulsion system will be the one part of this AV system. Apart from these two systems, there is third one, auxiliary subsystem. Mainly, it will have the temperature control unit, auxiliary power supply for various devices into the vehicle, and power steering supply, and other accessories into the car. After this EV configuration, we'll see classification of electrical vehicles. Based on the mode of working, the type of source used, the contribution of electrical input and IC engine input, these vehicles can be classified. And their classification, one will be the pure electric vehicle. So pure electrical vehicle will entirely run on a battery and electrical drivetrain without any IC engine support, or there is no any IC engine input. So it is a pure electrical vehicle based on the battery only. So electricity is stored on board batteries that are charged regularly, and then they will be discharged, or the supply will be given by the battery to the drive, and it will discharge. Again, we will recharge it. So this is how charging and discharging is done, and it will be purely run on the batteries. Another is the PHEV, plug-in hybrid electrical vehicle. So it's a type of hybrid electrical vehicle Once it is hybrid, it means there are two systems. One is the IC engine and another is the electrical propulsion. So hybrid electrical vehicle, if you see, it has an engine and a fuel tank, that is electrical motor and battery and IC engine. Similarly, a plug-in hybrid electrical vehicle will also have the same components, similar components, that is a battery, IC engine and a motor. But the difference is that hybrid electrical vehicles cannot be recharged from the power grid, while plug-in hybrid electrical vehicle, called as a gridable electrical vehicle or grid-connected electrical vehicles, they can be charged from the external source, that is from the grid. And in case of hybrid electrical vehicle, the battery will be charged by the input from the IC engine only and not from the external power supply. Another type, if we see classification, it is a range extended electrical vehicle called as a REV. It is very similar to the pure electrical vehicle and operates in the pure electrical mode regardless the driving range. Once the battery pack is depleted, it can operate in extended mode that the engine is turned on. So it has a small engine, that engine is turned on, which then drives the generator to produce the electricity, and it will charge the battery so that it will increase the range of the electrical vehicle. That is a range extended electrical vehicle. Now, in hybrid electrical vehicle, we can have subtypes depending on the how much is the contribution by the IC engine and how much is contribution by the battery energy storage or electrical input. It is you can say share of this electricity and share of the IC engine that will decide these subtypes of hybrid electrical vehicle. If you see hybrid electrical vehicles, so it has called as hybridization, which is less than 5%. Means how much is the contribution based on the electrical and based on the IC engine. So the electrical motor is a small integrated starter generator type of motor, is used to shut down the engine when the vehicle comes to stop and again to start up. So that is the mainly purpose of this IC engine. Once in motion, the vehicle is propelled by IC engine, and the electric motor does not provide additional torque to the vehicle. The fuel efficiency increases around 5 to 10% with the use of micro hybrid electrical vehicles. Now, another type is mild hybrid electrical vehicle. They are very similar to micro hybrid electrical vehicles. The range can be increased up to 10, increase size of the electric motor up to 10% of the IC engine power, and a battery that permits power assist during the vehicle propulsion. If you see the fuel efficiency, it is 20 to 30% for a real world driving situation compared to non-hybrid type of system. Another is the full hybrid electrical vehicle. So as it indicates, the batteries are significantly bigger so that it will be mostly contribute to the electrical propulsion. That is bigger than those of micro hybrid electrical vehicles and mild hybrid electrical vehicles. So depending on the vehicle's power demand, electric motor can be used as the sole power source. So vehicle can run only on the electric motor whenever it is required. So compared to micro and mild hybrid electrical vehicles, they have smaller engine and require more sophisticated energy management system. As battery is larger, engine is smaller. So typical fuel efficiency for hybrid full hybrid electrical vehicle is 30 to 50% for the real world driving compared to non-hybrid type of vehicles. So there is increase in the efficiency we are just discussing because of this hybrid electrical vehicles. Now the last one, which is the plug-in hybrid electrical vehicle. It possesses the same configuration of the full hybrid electrical vehicle, but the addition is it can be charged from the grid, and it has a much bigger electrical components, such that the battery and electrical motor, and a downsized engine. So engine size is again lesser, but battery size is larger. Here we can see the complete summary of the classification of electrical vehicles. So broadly, they can be classified as pure electrical vehicle, hybrid electrical vehicle, and also one more type is fuel cell electrical vehicle, where the propulsion or electricity will be produced by the fuel cell and it will be given to the vehicle. Now in hybrid electrical vehicle, it can be conventional hybrid electrical vehicle or plug-in hybrid electrical vehicle, that is called as a gridable hybrid electrical vehicle, grid integrated. Now in conventional hybrid electrical vehicle, we have discussed micro hybrid electrical, mild hybrid electrical, and full hybrid electrical vehicle. From this diagram, it can be observed that if this is the energy source side, this is the vehicle type, and this is the contribution by the propulsion device. So here contribution by energy source is indicated. Here propulsion either from the motor or from the engine is indicated and its contribution, and similarly here contribution of various energy sources if it is a hybrid type or it is a single one. Now if you see fuel cell electrical vehicle, the energy source is hydrogen completely. This is a complete portion of fuel cell electrical vehicle. Then hydrogen, it will produce the electricity, so completely it is operated on the electricity. So contribution will be 100% by the motor, electrical motor. If you move to the plug-in hybrid electrical vehicle, sorry, it is a pure electrical vehicle, we can see again contribution will be 100% by motor by using the electricity. So it is a pure electrical vehicle. Now another type, if you see a range extended electrical vehicle, the contribution of electricity is more as compared to the contribution of IC engine or gasoline or diesel based engine, that is IC engine. So major portion is by electrical motor and battery supply, and very small portion is by engine. So that is the range is extended by taking the support of a small IC engine. If we further move to the plug-in hybrid electrical vehicle, the battery size is slightly reduced as compared to range extended electrical vehicle, but it is sufficiently larger size, and engine size is or contribution of the IC engine is increased. Then if you go for the full hybrid electrical vehicle, further the contribution of electrical propulsion is reduced, that is the battery size is also reduced, motor size is also reduced, and engine size is significantly larger here. If you move further to mild hybrid electrical vehicle, engine size is further increased and contribution by the electrical propulsion is lesser, and in micro further contribution is very lesser and contribution of the engine is larger. And finally if you move IC engine, that is a conventional vehicles, 100% contribution by the engine or 100% contribution by the IC engine, that is petrol and diesel, that is a source. So this is how in an overview we can see the change from completely IC engine based vehicle to completely pure electrical vehicle. and fuel cell electrical vehicle. So slowly the engine size was reduced. If you move from conventional IC engine, then micro, then further mild, then full, again engine size was reduced and motor size was increased. And finally, we can move 100% electricity, no IC engine for PEV and FEV. Finally, we have discussed one term, that is a hybridization ratio. So hybrid electrical vehicle contains fairly large electric motor and associated batteries. It can be considered as a full hybrid. If we see the typical power rating of electrical motor in full hybrid passenger car, it is a 50 to 75 kilowatt. But if the size of electric motor is relatively small, then it is considered as micro hybrid. We have already discussed into the classification. Micro hybrid, on the other hand, does not offer the capability to drive the vehicle with electric motor only. The electric motor is merely for starting and stopping the engine. So considering these contributions by IC engine and contribution by electric motor, we can define the hybridization ratio. So here we can see a hybrid electrical vehicle with a motor rating of 50 kilowatt and IC engine rating of 75 kilowatt. We can calculate the hybridization ratio by taking the ratio contribution by the motor divided by the total rating, that is the total powertrain contributed by motor plus the IC engine. So 50 is the contribution by motor and 50 plus 75 is the total powertrain contribution. So we'll get the hybridization ratio of 40%. So in short, hybridization ratio, it provides the electric contribution over the total power contribution of the vehicle, power contribution of the vehicle.